Hello, I'm Guruprasad Upadhya. So, in the lecture 6 of the first module of 18MAT31, we'll discuss the Laplace transform of the periodic functions and Laplace transform of the unit step functions. The first question, find the Laplace transform of f of t equal to e sin omega t if t is between 0 to pi by omega and 0 if t is between pi by omega to 2 pi by omega. And f of t is periodic functions with the period 2 pi by omega. Now this is a half wave rectifier, that means in the half interval e sin omega t, in the remaining half it is 0 and it is periodic functions. Now the Laplace transform of the periodic function with the period t is 1 by 1 minus e power minus s into capital T, that is period, and integral 0 to capital T e power minus st f of t dt. Now substitute the value of this capital T and split the interval 0 to 2 pi by omega into 0 to pi by omega and pi by omega to 2 pi by omega, because in the half of the interval it is e sin omega t and in the remaining half it is 0. Therefore, 1 by 1 minus e power minus 2 pi s by omega, capital T is 2 pi by omega into s. So that is in the denominator, e power minus 2 pi s by omega, and integral 0 to 2 pi by omega is split into two parts. One is 0 to pi by omega e power minus st, f of t is e sin omega t, e is taken outside, sin omega t dt plus pi by omega to 2 pi by omega, f of t is 0, so that integral is 0. And we have the formula, integral of e power at sin bt dt is e power at by a square plus b square into a sin bt minus b cos bt. Here a is minus s, e power minus st divided by minus s whole square is a square, plus b square means omega square, and then a is minus s, sin bt sin omega t minus b is omega cos omega t. So this is integral of e power minus st sin omega t dt. Now you are applying the limit from 0 to pi by omega. Now if t is pi by omega, omega cancel, sin pi is 0, cos pi is minus 1. Therefore for the upper limit this value is minus of minus plus omega, e power minus s into pi by omega into omega, that is for upper limit. And for the lower limit, e power 0 is 1 here, and here sin 0 is 0, cos 0 is 1. So lower limit value is minus omega, upper limit value minus lower limit value, so minus of minus plus omega. By taking omega taken outside, then it becomes 1 plus e power minus pi s by omega divided by s square plus omega square. Therefore, so e by 1 minus e power minus 2 pi s by omega into upper limit value e power minus pi s by omega into, this becomes minus 1 into minus omega is omega into omega, minus lower limit e power 0 is 1, sin 0 is 0, here minus omega, minus omega is plus omega. Now by taking this omega common outside, e omega by s square plus omega square, numerator is 1 plus e power minus pi s by omega, 1 plus e power minus pi s by omega. Denominator is 1 minus e power minus 2 pi s by omega. And this is nothing but 1 minus x square, 1 plus x by 1 minus x square. 1 minus x square is 1 plus x into 1 minus x. Here x is e power minus pi s by omega. Cancel 1 plus x, that means 1 plus e power minus pi s by omega is cancelled. The remaining term in the denominator is 1 minus e power minus pi s by omega, that is remaining term. Therefore final answer is e omega by s square plus omega square into 1 divided by 1 minus e power minus pi s by omega. So this is the Laplace transform of this half wave rectifier. One more example, f of t is t by capital T and t is between 0 to capital T, and f of t is periodic functions with period t. See this function, how it looks. In the first period 0 to capital T, f of t is t by capital T. When t is 0, f of t is 0. When t is capital T, f of t is 1. So 0 to 1 it goes, and then next 0 to 1, 0 to 1. So it is like this. So it is like sawtoothed wave. So Laplace transform of this sawtoothed wave is here capital T is the period T is t itself. Therefore, Laplace transform of this f of t is 1 by 1 minus e power minus s into capital T is into integral 0 to capital T e power minus st f of t dt. Now this f of t is small t divided by capital T. Now capital T is constant, you can take outside. So t into e power minus st dt 0 to t, 1 by t into 1 minus e power minus st. So into 1 by t 0 to t e power minus st dt. You know how to integrate this. The first function is t, minus derivative of this first function is 1, integral of the second one is e power minus st by minus s, again integrate this e power minus st by minus s into minus s is s square. Apply the limit 0 to capital T. For the upper limit it is t e power minus s capital T divided by minus s. Lower limit is t0 means this is 0. Here upper limit is minus e power minus s capital T by s square. Lower limit is e power 0 is 1 by s square, minus of minus plus 1 by s square. So 1 by 1 minus e power minus s into capital T into 1 by capital T into e power minus s into capital T by minus s minus e power minus s into capital T by s square plus 1 by s square. This is lower limit value is minus 1 by s square, minus of minus plus 1 by s square. Now by taking s square common outside, you can multiply this by s, or you can simplify this separately and this separately. Here if I take minus sign outside, 1 minus e power minus st by s square, multiply by this 1 minus e power minus st cancels, 1 by s square remains into t. Therefore by combining these two terms, so it is 1 by t s square, these two, and first term cancel this t e power minus st with this minus sign, minus e power minus st divided by, so t is cancelled, s into 1 minus e power minus st. So this is the first term, multiply these three terms, so you will get this. Second and third term, combine these two, this is 1 minus e power minus st, 1 minus e power minus st cancels, 1 by s square remains, here 1 by t, so 1 by t s square. So this is how we can simplify. Now we discussed two problems in periodic functions. Same logic, if you know this formula and some basic integral concepts, you are able to find the Laplace transform of the periodic functions. Now about unit step function. Find the Laplace transform of the following functions by expressing them in terms of the unit step functions. Now before expressing the given function, step function to unit step function, first you check whether it is defined from 0 to infinity. Yes, it is defined from 0 to infinity because it is given 0 here otherwise. Therefore, first function in this f of t is 0 from 0 to 1. So f of t can be written as 0 if t is between 0 to 1 and t minus 1 if t is between 1 to 2 and 3 minus t if t is between 2 to 3, and if t is greater than 3, assume that it is 0. Totally 4 functions from 0 to infinity. In the first interval it is 0, in the second interval it is t minus 1, in the third interval it is 3 minus t, and in the fourth interval it is 0. Therefore, we can express this f of t in terms of unit step functions such that first function, that is 0, plus second function minus first function t minus 1 minus 0, that is t minus 1, into unit step function t minus a means here 1 common to these two, first and second. So u t minus 1, then plus third function minus second function, that means 3 minus t minus t minus minus 1, that means 3 minus t plus 1. So 3 plus 1 is 4, minus t is minus 2t. Take minus t outside, so t minus 2 it becomes t minus 2. See, if you simplify this, minus 2t, yes, here minus t, third function, minus second function means minus 2t, and then 3 minus minus 1 means 3 plus 1 4, so minus 2 into minus 2 is 4 plus 4, minus 2t plus 4 can be written as minus 2 times of t minus 2 into unit step function u t minus b, b means here 2 common to third and fourth, so b is 2, so u t minus 2, and next fourth function minus third function 0 minus 3 minus t, 0 minus 3 minus t is nothing but t minus 3, t minus 3, u t minus c, c is nothing but 3 here, so u t minus 3. So this is how we can express f of t as a unit step function, and we know that Laplace transform of f of t into u t minus a. To find the Laplace transform of f of t into u t minus a, first you multiply it by e power minus a, first term is e power minus a, then in f of t replace t by t plus a, then find its Laplace transform. That means Laplace transform of f of t plus a into e power minus a. Now f of t is t minus 1 here, a is 1 here, e power minus 1s into Laplace transform of f of t plus 1. So f of t is t minus 1, f of t plus 1 is t plus 1 minus 1, so t, f of t. Here also e power minus 2s Laplace transform of f of t plus 2, this t plus 2 minus 2 is f of t, that means t, minus 2 times of Laplace transform of t. Here e power minus 3s into Laplace transform of f of t plus 3, t is replaced by t plus 3, t plus 3 minus 3 is t, so Laplace transform of f of t, that is t, and hence Laplace transform of f of t becomes e power minus s into Laplace transform of f of t plus 1, so t plus 1 minus 1 is t, so Laplace transform of t plus e power minus 2s into minus 2 into e power minus 2s into Laplace transform of f of t plus 2, t is t plus 2 minus 2, that is t, Laplace transform of t. Last one is e power minus 3s into Laplace transform of f of t plus 3, t is replaced by t plus 3 minus 3, that means t here, Laplace transform of t. Here common term is Laplace transform of t, that we know Laplace transform of t is 1 by s square, and hence the final answer is 1 by s square into e power minus s minus 2 e power minus 2s plus e power minus 3s. So this is Laplace transform of this step function f of t. By the help of the Laplace transform of unit step function, we got the answer. One more example, f of t is sin t in the interval 0 to pi, sin 2t in the interval pi to 2 pi, sin 3t in the interval 2 pi to infinity. Therefore, first function sin t plus second function minus first function sin 2t minus sin t into unit step function u t minus pi, and third function minus second function into unit step function u t minus b, b means 2 pi, and then apply Laplace transform. Laplace transform of f of t is Laplace transform of sin t plus here f of t into u t minus a e power minus as e power minus pi s Laplace transform of f of t plus pi. So t is t plus pi, sin 2 times of t is replaced by t plus pi and sin of t plus pi. First you simplify this, then find Laplace transform multiplied by e power minus pi s. Here also e power minus as, a is 2 pi now, e power minus 2 pi s into Laplace transform of f of t plus 2 pi. In the place of t, write t plus 2 pi, sin 2 t plus 2 pi. And in PUC you studied sin 2t plus 2 pi. 2 pi is periodic function of sine, therefore you can cancel 2 pi, so it is sin 2t. And sin t plus pi, in the third quadrant sine is negative, so minus sin t it becomes, so minus of minus plus sin t. And this is so Laplace transform of sin 2t plus minus minus plus Laplace transform of sin t. Here 3t plus 6 pi, 3 rotations, after 3 rotations 3t. So cancel 3 periods, so it is sin 3t, sin 3t. Here also 2t plus 4 pi, 2 pi plus 2t, therefore it is sin 2t, sin 3t minus sin 2t. And you know that Laplace transform of sin at is a by s square plus a square, apply that. Therefore sin t Laplace transform is 1 by 1 plus s square plus 1 plus e power minus pi s into Laplace transform of sin 2t 2 by s square plus 2 square plus sin t 1 by s square plus 1 square plus e power minus 2 pi s into Laplace transform of sin 3t, that is 3 by s square plus 3 square minus sin 2t Laplace transform 2 by s square plus 2 square. So this is how we can find the Laplace transform of this step function by expressing this function as a unit step function and then find the Laplace transform using the formula of Laplace transform of f of t into u t minus a, that is e power minus as into Laplace transform of f of t plus a. So this is how we can solve Laplace transform of this unit step function. One more example, f of t is sin t in the interval 0 to pi by 2 and cos t in the remaining interval. That means if t is greater than pi by 2, it is cos t till infinity. Therefore f of t is sin t plus second function minus first function cos t minus sin t into u t minus a is pi by 2, u t minus pi by 2. So its Laplace transform is Laplace transform of sin t plus e power minus as, a is pi by 2 minus pi by 2 s into Laplace transform of f of t plus a. So t is replaced by t plus pi by 2, t is replaced by t plus pi by 2. This is f of t plus pi by 2. F of t is here cos t minus sin t, f of t plus pi by 2 is cos t plus pi by 2 minus sin t plus pi by 2. And this is pi by 2 plus some angle theta or t, cos becomes sin, sin becomes cos, that means co-angle, complementary angle. So it is, but pi by 2 plus t means it is in second quadrant, cos is negative, therefore it is minus cos sin t, cos t plus pi by 2 is minus sin t, and sin t plus pi by 2 in second quadrant sin is positive, but sin becomes cos here, therefore it is cos t, this minus remains. So minus sin t minus cos t, take minus outside, minus e power minus pi s by 2 into Laplace transform of sin t plus cos t. So by taking minus outside. Now Laplace transform of sin t is 1 by s square plus 1, take minus outside, e power minus pi s by 2, e power minus pi s by 2. Laplace transform of sin t is 1 by s square plus 1 plus Laplace transform of cos t is s by s square plus 1. Combining these two, so it becomes 1 plus s by s square plus 1 or s plus 1 by s square plus 1 into e power minus pi s by 2. Okay. So finally this Laplace transform of this f of t is 1 by s square plus 1 minus e power minus pi s by 2 into 1 plus s by s square plus 1. Now, so we discussed some Laplace transform of some functions, special functions, but what is the use? How we can use the concept of Laplace transform to evaluate some complicated problems? Here the question is not to find Laplace transform. Evaluate this integration 0 to infinity t e power minus 3t sin t dt. Actually, we don't have any concept here. The question is not to find Laplace transform. Find the integral value. So, evaluate 0 to infinity t e power minus 3t sin t dt. Now, just think about Laplace transform of f of t. The main formula of Laplace transform of f of t is integral 0 to infinity e power minus st f of t. So, integral 0 to infinity e power minus st f of t is sin t, t sin t. Assume that t sin t is your f of t. So, this is nothing but Laplace transform of t sin t. And we have the formula of Laplace transform of t sin t without integration. We are able to find the Laplace transform of t sin t by applying the second rule, that is minus d by ds of Laplace transform of sin t, that is 1 by s square plus 1. So, denominator in the denominator square, that is s square plus 1 whole square is in the denominator. In the numerator, denominator into derivative of this one is 0. So, first term is 0 minus 1 into this 2s. So, minus 2s. Here is one minus sign. So, it is 2s by s square plus 1 whole square. So, by applying the second rule, t sin t Laplace transform. See, we know the Laplace transform of t sin t, that is 2s by s square plus 1 whole square. It is nothing but integral 0 to infinity e power minus st t sin t dt. So, what we did? We just apply the Laplace transform of t sin t. Now, compare these two. See, integral 0 to infinity t e power minus 3t sin t dt. Here, integral 0 to infinity t e power minus st sin t dt. In the place of s, here it is 3. Therefore, put s equal to 3 both sides. So, this is left hand side, put s equal to 3. Here also put s equal to 3. Now, when s equal to 3, left hand side is 0 to infinity t e power minus 3t sin t dt. In the right hand side, 3 to the 6 by 3 square, 9 plus 1, 10 square is 100. 6 by 100, that is 3 by 50. Cancel 2, so we will get 3 by 50. See, we got the value of this integral with the help of this Laplace transform of t sin t. One more example. Suppose you want to find the value of 0 to infinity cos at minus cos bt by t dt, this integral. So, we do not have any formula to integrate this type of functions. Then what to do? Assume that this is your f of t multiplied by e power minus st. So, 0 to infinity e power minus st f of t dt is nothing but Laplace transform of f of t, that is cos at minus cos bt by t, and use the rule 3 to find the Laplace transform of cos at minus cos bt by t. So, that is integral s to infinity Laplace transform of f of t. Here f of t is cos at minus cos bt, that is s by s square plus a square minus cos bt Laplace transform s by s square plus b square. And we have the formula for integral of s by s square plus a square ds, that is log root s square plus a square minus log root s square plus b square, and log a minus log b is log a by b. Therefore, it is log root s square plus a square by s square plus b square from s to infinity. For the upper limit, when s is infinity, so this becomes 1, log 1 is 0, 0 minus log a by b is nothing but log b by a. So, final answer log root s square plus b square by s square plus a square. So, this is Laplace transform of cos at minus cos bt by t. So, that is nothing but integral 0 to infinity e power minus st cos at minus cos bt by t dt. And to get the integral value of this, see what is s value? E power 0 t. If s is 0, e power 0 is 1. So, you will get this one. Therefore, put s equal to 0 here and here. When s equal to 0, when s equal to 0, 0 to infinity e power 0 is 1 cos bt minus cos at minus cos bt by t dt. When s equal to 0, root b square by a square is root b by a. Root b square by a square is nothing but b by a. So log b by a. So integral of 0 to infinity cos at minus cos bt by t dt is nothing but log b by a. So similarly, some complicated types of this integral can be value of the definite integral can be obtained using this Laplace transform. So please remember the formula of Laplace transform of f of t, that is 0 to infinity e power minus st f of t dt. With the help of that, so you are able to find the integral value, definite integral value by the Laplace transform method. Thank you.